get started. Yeah. Okay, practice exam number 2.
We're having an exam tomorrow?
Next Thursday. We'll have an exam next Thursday. Next Thursday. No. No. I need the whole spring break to grade it, so this is going to be brutal.
So you're going to have our grades for us, the first class after spring break?
Possibly.
Oh, if you give it to us before you have to.
Or halfway through spring break, so some people don't have to come back from spring break.
Not a bad idea.
All right. So let's go ahead and get started. This is your practice exam number 2. And let's go ahead and get started. I can see that people are no longer sitting in the very back row for some reason. You know, just kind of, I just noticed it. It's like,
There's not any more electricity back there than there is up here.
Sorry?
There's not any more electricity back there than there is up here.
Really? Huh. The clock is still running. Okay. So this is the practice exam. It is not a practice exam from before. This is an actual exam from, I think, last year or year before last. I cannot remember which semester. So 1 year, this is actually an exam. So the instruction is going to be about the same for this class, for next Thursday, not next Tuesday. I will not be here on next Tuesday, so we'll cancel class on next Tuesday because my wife has a business trip down to San Diego, so I have to stay home and watch the kids. So most likely,
you can bring him in with you.
Huh?
Raj has done it. You can bring him to class with you.
Raj has done that?
Yeah.
Okay.
I guess we'll talk about that one next meeting.
Yes, in a departmental meeting. Okay.
So we have no class on next Tuesday?
Next Tuesday there won't be any class. I will see if I can make a video clip so that you guys can watch the video clip as taking a class. So this is the first time I try something like this.
Instead of this?
You guys can do that at home, and I cannot see whether you have watched the video or not, so I can only assume that you guys have.
Can we send our questions before the video clip to you? Email it to you?
We're still meeting this Thursday, so we still have one class before the exam. You can send me questions if you want to, or make it to my office hours. That would be good too.
What's the video we can keep in the background?
Sorry? All right.
Why not just do a live webcast where we're all watching and can ask you questions in chat?
If you want to watch me getting beat up by my kids, in a Wii game, you can watch it live.
Okay, why not give us a live screen webcast?
Screen webcast.
You with your microphone.
Okay.
Screen.
Okay, let me just put the actual test schedule up so that we don't forget what day we're gonna have it. Okay, so we're gonna have the test next Thursday because I won't be here next Tuesday. So next Thursday is when we have our second examination. So that means you have 9 days from today to take the exam. Okay, so do you guys want to take it in the lab? Because the only way we can do it is to do it in the lab after the lecture hours or lecture time. So we'll have to do it during the lab time, because at this time there's no space in the lab to put this class there. This is still a big class.
Just only 1 hour?
What?
The time.
The lab,
She's inquiring about
the
the
lab
time.
is going to be closed at 10 o'clock.
Yes, they will close at 10 o'clock, and we'll be there at 8:30. Or as soon as Clarence's class clears out, because that's one bigger class too. So I have to arrange with the lab people and see at what time we can get into the lab. But that's it. That's Walter will toss us out at the right time.
Yes, lab, you can't make us do another paper exam. That was atrocious.
Yeah,
That was completely unfair.
Unfair? Did you get a different question than the rest of the class?
Question number 2 was because we had
Without the
no
computer
way
to test it, yeah, that was way unfair to make us try and answer those questions without any way to test our code.
Da, 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 da. Oh, wait.
So anyways, yes, we would like to do it in the lab if possible.
Okay, this is exam 2. So what I'll do is I'm just going to schedule the time, so this way it appears in Moodle, so we don't forget we'll have a test on the 14th.
If you'd like to make it available from today, that would also be acceptable.
Then I'll have to make it so hard that you guys cannot actually do it yet.
Sure we could.
No.
We've got Google and the interwebs. We know how to research.
Yeah, but we're lazy.
We're college students. We've learned this.
You can just go to Craigslist and list in help wanted, right?
I'll have an ad up. Need help with your assembly prototyping?
Just go to Craigslist and say help wanted.
That says 9:45.
Yes.
No, it's 21:45. 9:45 is too early. I can't get up that early.
Just 9:45.
Okay, so right now we do have exam number 2 scheduled for next Thursday. Okay, so make sure that you come to the class, on next Thursday, and the time is not during the lecture; it is during the lab time, because there's an overwhelming percentage of students who want to take it online instead of taking it on paper. Do you want to take it on paper?
You can do so in the lab.
Print it out and do it on paper.
Yes.
Can you determine how are you going to grade these when you are taking the exam?
I refuse to assess the difficulty of my own test because every time I say something about the difficulty of my test, it always comes back and bite me big time.
Yeah.
So I just won't say anything.
That's probably a good idea.
No, if you are like question number 2, you didn't give anybody any partial credit. Like
This one will have partial credit.
okay.
Yep, I'll design it so that we can assign. I can give people partial
I
credit.
got right.
Are we having a lecture before the test?
We're going to have the lecture before the test. We can go over things, if people want me to go over particular concepts. Yep. What's up?
Oh, what's the date again?
That's Thursday.
It's on Moodle. It's on the
calendar
14th.
right there.
Look at the screen.
I looked. I couldn't see it.
Da, 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 da.
14th of April. Okay.
Yes.
Meet you. Let's go to the
Okay.
14. This class. Go to the event.
All right.
Only this event.
So it is now scheduled, and so what we'll do today? Yes.
The
Go
way
ahead.
the practice exam is set up, so we download the file, we can work at it whenever we want, and then what is the down below is what is the submitting about? Keep going.
No, we don't
Yeah,
have
what
to.
is
Oh, it says something about when you do it from the student side. I think, do we have to do that, or is it just about downloading the file, basically?
That's interesting. That's not what I saw a little bit earlier.
Oh, maybe I was misinterpreting it. Is that the student view? All the way at the button.
No, there should be a link to a file.
Yeah, you have to take it, right? Yeah, it says attempt quiz or something like that.
Oh, there we go.
So
I just need to attempt.
There's not like
continue the
a
attempt.
one-time thing or anything like that?
No, this one you can submit it and then you can try again. You can try as many times as you want.
All right.
Are you going to grade this?
No, this one is not going to be graded. This one is just a practice test.
You will post the answers or something?
I'm going to work on it today.
Oh. Well,
Yeah.
that's no
So no fun.
Well, we can't attempt them after. Well, that's fine.
Well, I can explain it at least, so that
Yeah.
at least people know what this is about. If you guys prefer, we can talk about it on Thursday, so that you guys have a chance to work on it first.
I'd appreciate it.
Okay, that would be fine. Okay, so this one is about using multiplication and division in order to find the, let's see, GCF or LCM of something. So, okay, anyway, let's look at the code. The commented code is written in C, so your job is to fix the program so that it works the way it is described in the C code. Okay? So right now the program does not work. Okay, it has some of the code, but it doesn't work just yet. Here is find factor written in C. The C version is correct. In other words, the logic of the C version is correct. So the question is, what are we going to do with the assembly version. Now this one does not involve the use of passing parameters on the stack. So all that stuff about using the stack pointer, the frame pointer, and stuff like that is not in the scope of this particular test. So it will test all the way up to call and return, push and pop, and the stack pointer, but we are not passing parameters on the stack. Is that okay? So your homework is actually ahead of the scope of the test, because in your homework, you'll probably exercise, the concept of passing parameters on the stack before, we take and the test does not include those topics.
So those topics will.
Sorry?
You mean section 9, so operating system of program?
That will be included.
Okay.
Yeah. The operating system thing, is not really, there's not much to it. It's really, about, which EAX or what value do you put into EAX, and then what other register do you need in order to read a byte or to write a byte. So that one, I don't think there's a whole lot of stuff included in the operating system concept. Okay, so here's the C code and here's the assembly code. It does not work yet, so your job is to check and make sure that it works. Okay, find out where the bugs are, fix the program so that it works. So here's one procedure, and here's another subroutine. One is called find factor. Find factor, for those of you who took cisp310 from me, this should be like super duper boring stuff, because this is like the nth time you see something like this in my classes. Okay, I can explain this a little bit. Do you guys want me to explain it? How you find a prime factor given a number? Yes? Yeah. You guys are all going back to elementary school.
Yeah. You started with adding.
Okay, so the way we do it is we basically start with 2, because 2 is the smallest prime number there is. And then what we do is we stay in the loop as long as f times f is less than n. N is the number that we want to find the prime factor from. And as long as n mod f does not equal to 0. Because if n mod f does not equal to 0, it means n is not divisible by f. So that means we have not found a prime factor of n just yet. If both of these conditions are true, that means I cannot give up yet, because n itself is not confirmed to be prime, and I can still have other factors that I may be able to find. I haven't found one yet. When that happens, I just increment f, so that f bumps up to 3, and then bumps up to 4. Now, I know we should not be trying 4, because 4 definitely won't be a prime factor when 2 is not a prime factor. 4 is not even a prime number. But the program is not incorrect. In other words, it will not accidentally recognize 4 as a prime factor. So it's just burning, it's wasting processing cycle, but it won't give you the wrong answer. Yes?
If n mod f is equal to 0, you've requisitely found the first
Prime
factor, even if that first prime factor is n.
Yes, but this is smart. I can get out way earlier.
Yeah, I'm just saying that if you find an f, it's guaranteed to be... Wait. Okay, carry on.
Okay. So when we get out of the loop, we have to check whether f times f is greater than n, because if f times f is greater than n, that means n is prime, and as a result, the prime factor is n itself. Okay? Is that okay? The logic of this code is definitely working. You haven't seen this symbol before, especially if you don't take cisp310. That's the assignment operator. In my cisp300 class, I do not use the equal sign to mean assignment, because the equal sign, is actually ambiguous. Math people will look at it as equality, and programming people will see it as assignment operation, and that's why I use the left arrow symbol to mean assignment.
So it means F equals N.
Yes, in C. Yep. And here's the code. There may be a problem with it. You have to fix it. And here is, find GCF, or find greatest common factor. Now, find greatest common factor is based on find factor. So basically, we want to look at x and y. We want to find the greatest common factor between x and y. And we start with an assumption that the greatest common factor is 1 to begin with. And here we say as long as x does not equal to 1, we'll keep doing the rest. So we'll use n. I'm not using the symbols consistently. This is assignment 2. N gets the value of x. So basically we are finding a factor for x itself. And then we'll say while x mod f equals to 0. In other words, we find one single factor, but we'll use the same common factor to try to reduce x as many times as we can. For instance, if I start with 16, it will find a prime factor of 2. But 16 is 2 to the power of 4, so this loop will keep looping because we can reuse the same factor. Is that okay so far? So x will get reduced by f, and I will check to see if y can also reduce by the same amount. If y can also be reduced because f is also a common factor in y, then I'll do the same thing to y, and then GCF will be multiplied by f. Because I found another common prime factor between the two numbers. So I'm just going through this loop here. There's an outer loop, there's an inner loop, to try to find all the common prime factors between the two numbers. I multiply all the common prime factors, and then I have the greatest common factor between the two numbers. The code works. If you put it into like a Visual Basic program, you can see that it works. Yep.
So we're doing x modulus f, and if our 0 bit is set after that, can't we just copy x from the register to do the x divided by f?
Yes, you can.
Okay.
Yep. And I have my own program down here, which is also incorrect. The program, may contain, errors, so it doesn't really do whatever it is supposed to do, but it's pretty close. Okay, it is pretty close. And here we have find LCM, find the least common multiple between two numbers. And that's pretty easy to do because once you have find GCF, you can use that to calculate, the actual LCM. Is that okay so far? Does everybody understand, how to calculate or how to find the least common multiple once you have the greatest common factor? No? This is how you do it. You take one number, you divide it by the GCF, and then you multiply it with y. You could, potentially, you can also do the multiplication before you do the division, but you can possibly run out of range if you do the multiplication before the division. So that's why I do the division first, and then we multiply. So the next question is, are we sure that we can divide x by GCF first? Does it make sense?
That was the whole point.
That's the whole point. It is the greatest common factor. It has to be a factor of x. So x divided by GCF has to be at least 1, because the greatest common factor can be x itself. Okay, so this code works. Okay, you just have to make sure that you do the same thing. And in this case, find LCM is blank, which means you have to implement this particular subroutine. I don't think this is going to be a big deal, okay, because it's one call to find GCF, and then you go through the calculation, and then you're all done. Yes?
I'm curious how find LCM, find GCF, and find factor are supposed to work if we're not passing parameters.
We are using global variables to pass variables.
Okay.
In other words, when you look at the main program, okay, this is basically the main program, but since we don't have main, we use underscore start as the entry point of the entire program. So you can see that when we do the x equals 36 and y equals 48, I'm just moving those constants into x and y, and x and y are
Find all the way up there.
all defined here. They're all statically defined, and they are basically global variables in C. So in this program, we are not passing parameters using what we have been talking about in this class to kind of make things a little bit less complicated. There's no recursion in this code, so no stack-based parameters or local variables should still be fine. Yep.
Are we doing 32 bits division?
We use 32-bit division and also 32-bit multiplication. The instruction to use division is already, we talked about that already in the class, and then the instruction to use multiplication is also stated here. Okay. Any questions about this, practice question for exam 2? We can do that on Thursday. or I can do it using a YouTube video, so that way we don't use up any class time. You guys can watch it when you want to. So we can do it either way. Kind of like our homework assignment from last week. I did not spend any time in the class to talk about the solution. So instead, I do the same thing at home and just kind of mumble to myself. Push it onto YouTube and call it the solution.
Something goes wrong, you start swearing at the computer screen, and then realize we're still listening.
Yeah. There's a beep, alarm beeping out something. So is that okay so far? I mean, do you guys understand the nature of this particular question? Okay. Now, how would you get started? Okay, I'm not going to give you the solution today because I know some of you want to try it out and see if you can get it done. So how would you approach this problem? First of all, yes, go ahead.
I think step 1 would be to delete your code.
I'm pretty sure that will, well, I mean, if you want to recode the whole thing from scratch, I mean, be my guest. Yep.
I would start with writing find LCM. The one where you write all the assembly code for.
Start with the easy one.
Start with this
No,
one?
yeah.
Oh,
That one.
this one?
Yeah.
Well,
It's gonna
that
be
makes
short.
it really hard to assign partial credit. Now, let me tell you how I can assign partial credit when it's a program like this. The partial credit will be assigned, when I test the individual subroutines one by one. The question is this set up to do that? Can I, test the subroutines individually and assign partial credit based on the functionality of the subroutines one by one? The answer is yes. It is all set up to do that. Okay, let's take a look. The main program calls find LCM. Okay, so find LCM is over here. This is something that you have to implement. But you cannot get find LCM to work unless you have find GCF working. So here we have find GCF, but find GCF relies on find factor. So the first thing you have to do is to start with find factor and make sure that it works first. So when I test your program, I will first test whether find factor is working or not. If find factor works okay, then you will get some partial credit because find factor is working. Then I will test your find GCF. If your find GCF is also working, then you get some more partial credit. And then I will test your find LCM. If that's working, you'll get some more partial credit. And if the whole program works, then you get all the points. So that's how it is all staged and set up so that you can have partial credit as you work on this particular assignment. And that's also a good reason why you don't want to start with find LCM.
Well,
because
writing find LCM is no problem.
Right, but making sure that it works is a little bit hard.
Well, I go through, just write it first and forget about it.
Yeah, but you can't test it, unless you have all the other stuff that's working too. Okay, so now that we know we have to start with find factor, how would you do that? I mean, we have quite a bit of code here to implement the C code over here.
I would start.
Pseudo C code.
I'd just start moving the code up a little, just to see if it makes sense.
Mm-hmm. You may move the comments down so that you can match up the comments to the C code.
Yeah.
Yep, that makes sense. And when I give you a program like this, I don't use shortcuts. So for the most part, there won't be any shortcuts. So the logic of the C code or the pseudocode will be reflected in the actual assembly code. Okay. So I'll let you guys give it a try. Give it a try over the next 2 days or so. You don't have to finish it. It's not going to be graded. Just spend some time to try to do it. If you cannot get it done, don't worry too much about it. On Thursday, I can talk about it in the class, or I can release a video clip on YouTube first so that you guys can watch it on YouTube. And if there are any questions based on the YouTube clip, then we can talk about it in the class. How does that sound?
I like this.
Okay. It's multimedia. Okay. So I'll let you guys give it a try first. Okay, just to make sure that everybody has a chance to at least give it a try and assess okay, how am I going to do it? Okay, next, I talked about revision control for this homework assignment that is due on Thursday. Does everybody know what is revision control? No? Yes? Sort of? Okay, never heard of it? Okay, revision control is very, very helpful. Okay, especially when you're writing code in assembly language. When you're writing code in C, obviously you can make very small mistakes, and then break the program. For instance, you can change a less than into a less than or equal to, and then your program suddenly doesn't work anymore. Yep.
Or better yet, a double equals one equal sign.
Yeah, well, then you just have to crank up the whiningness of the compiler, because a lot of times the compiler can whine about that if you turn on all the warnings. But that's a very common problem. And if you don't turn on the warnings, it actually does not complain, and then you end up with big problems. But in assembly, it's even worse, because you can use the wrong width when you specify a move instruction or a compare instruction, and that will break the program out of right there. So what you want to do is to use revision control so that you can compare changes that you have made to the program at different points of time. Okay, the moment you get something that works to a certain point, you check, quote unquote, check in the program. Then you make some additional changes. Now let's just say that you make the additional changes after 2 beers, and it made the program worse. Okay, it happens all the time. I have done many of that. During my spreadsheet, coding experience. Okay, it will be like 2 or 3 a.m. in the morning. And then, the buddies and me will walk down. The university is actually located mid-hill, so we have to walk all the way down to the coast, in Hong Kong, and get some beer, and then we'll eat something, and then we'll just kind of stumble our way back up, into the lab. And then for the next hour or so, there won't be any coding. And then, after that, there'll be some coding, except probably we should not have been coding, at that time. Okay, so you do make changes, to your program that sometimes can make the program worse. What used to be working is no longer working. Without revision control, how do you know what changes you made when you were drunk? It'll be pretty hard, okay? Now, with revision control, you can just ask the revision control software and say, compare the current code to the program of this version at this time. It will show you all the differences. Now, as long as you did not make massive changes, during that time period, it can locate exactly all 6 changes that you have made. If one of the 6 changes broke your program, it will be pretty easy to spot, because you only have 6 changes to evaluate and see which one broke the program. So revision control works really well when you're writing programs by yourself without a team. It works even better when you have a team of people, because it allows multiple people to check out one single file. As long as you do not make conflicting changes, the program can actually keep track of all the changes made by different people to the same file. Now that can be very helpful, because what you can do, with object-oriented programming especially, is, some people can pick up, okay, I will implement these particular methods, and I'll be implementing the other, methods. As long as the methods do not require conflicting changes to the source code, the revision control software can keep track of all those changes independently. Now, let's say, me and Christ, are working on the same program, and I'm the one, who is done first. What I can do is I can release my changes back to the repository, and Christ can import, the released code that I have, and incorporate it into his program, which is still under development. So that can be done with a group-based revision control program. It's just, very useful. You only need to have, web access, internet web access to get this done, and you can now, work with someone, across the globe, to cooperate on the same project. So personally, I just think it is a great idea, not only for assembly language programming, just in general, it is a great idea. Now, having talked about all that stuff, let me just show you how easy it is to set it up. So let's go to see 2011-04. What is today's date? 05. Today is 310. Okay. So I'll just go ahead and copy and paste this code here. What is the name of that code? We'll just call it GCF.
That's not an F.
Hmm? That's
not
not
an
an
F.
We can fix it.
That's not a control D.
Yes. Okay, first change the name GCD to GCF. And then change the last line because I made some control characters at the end. Okay, so here's how you set it up. Okay, if I don't remember how to set up RCS, this is how you do it. Man RCS intro. So in other words, it's not just telling you how to use a particular command. This is an introduction. Oh, it is not installed. Okay, aptitude install RCS. That may or may not work. Nope.
You need sudo aptitude install.
We have to do that on our virtual machine too.
No, I think your virtual machines have RCS already installed.
Did you add Git to the virtual machines too?
Hmm?
Did you add Git to the virtual machines too?
What? Did I
Git.
install Git?
Yes.
I think so.
Okay.
Well, give it a try.
I'm surprised you still use something as old as RCS.
Okay, now I have RCS installed. I can say man RCS intro, and that shows you how to use RCS. And if you scroll all the way down here, it shows you that you have to make a folder called RCS, and then to check in a program, you just use CI to check in a program. You can also specify CI, if I remember correctly, -L to keep a file locked, like this. Okay, I'll just show you how exactly to do it. So we have to create a folder called RCS, uppercase RCS. It has to be that name exactly. And when you're ready to check in, I will check in the program as soon as possible. So I will check in gcf.s right here. And I want to enter description for the file at this point. Okay, this is a program that computes GCF. Okay. Okay, so that's my first version. Now I go in and I will make some changes to the program. So let's just say that I go to this program and I start to make some random changes to the program. Okay, blah 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 blah. Because I'm drunk.
Is that a memory operand or a register operand?
Because I'm drunk. Coding under the influence. Okay. Developing under the influence is a DUI. Okay, so here we have the program all messed up. Okay. Now obviously in this case if I actually did that, it's not too bad because the assembler would have spotted all those problems. But if you put in valid instructions or change existing instructions to something else, then it's much more difficult to remember. Okay, but what did I do to the program? Okay. But let's do something else. Okay, let's just we go through the program and just randomly delete lines, which obviously is one great way to make new questions, right? Just finish a program, make sure it works, and then go in and randomly delete the instructions. There we go. Okay, so now this program is kind of messed up because I inserted new lines, deleted existing lines, and I can make it okay. Let's make it even worse. Okay, to make it worse, I can go into a line and just remove, certain characters, like that, or I can go here and change that.
Start changing with.
Yeah, and just add parentheses, over here. Okay, so I'm all good. I think I fixed my program now. Wow. So now how do I find the difference? Okay. So what you can do is you can use RCS diff. If you want to compare to the last revision that you checked in, you can say RCS diff and then just give it the file name, which in this case is gcf.s. I will pipe the output to less just so that we can see the output. So this is the native output of RCS. It shows you the differences. On line 43, it is changed. The letter C means something has been changed. It shows you that line 43 is line 43 in both files. Okay, and it also shows you that in the original file we have this line here. In the other file we have that. This is the new file. So whatever is to the left-hand side is the first or original file in the repository. Whatever is on the right-hand side is the modified file. Now, why does it show like that? It's because I deleted that line and replaced it with gibberish. Okay, so that's why it is reported as a change. The other one is also reported as a change, which is line 56 of the original file of the one that I checked in, and line 56 of the current version of that file. The original one has this content with a % before the EAX. The new version has the % symbol removed. Over here we have also a change on line 84. Once again, it is line 84 of the checked-in version, and also line 84 of the current version. And the change obviously is the $sign. And then we have a deletion here. Now this line means on line 88 of the checked-in version is deleted. So there's no such line anymore in the new version. Okay? And it shows, and here we have another change. On line 83 of the original file, it looks like this. On line 92 of the new file, it looks like this because I added parentheses around the registers. This is append. A stands for append. Line 94 of the original file does not have the following content because it is actually appended. So line 94 of the new file has this gibberish here, but it was not in the original check-in version. And we have another deletion here. Line 108 of the original version has been deleted. Line 121 of the original version is deleted, and I inserted line 143 in the new version that has all this gibberish. There's also a way to make it, I think Vim can do that. Vim div gcf.s. No, it's not. Oh, I have to give it two versions, I think. Yep, I have to give it both versions.
How do you do that since they're named the same? How will you do that since they're named the same?
Well, I'm going to have to look into RCS and find out how to do that. There's a command for you to check out a file, check out the last version of it. Vim diff may be able to do that too. Let me see if, nope, it doesn't know how to do with RCS. This one is for checking out a particular version. Retrieve the latest revision whose number is less than or equal to that. Same as -r exhibit logs the retrieved version for the caller. Okay, so one thing we can do is to move gcf.s to gcf.new.s, because that's the one that I changed, after I got drunk. And then we can check out gcf.s again. So now we have two files. We have gcf new and then gcf. Now we can use vim div gcf.s, which is the original. This is the one that we checked in. And then gcf_new.s, which is the one that is messed up. And this is even better because it has got syntax highlighting. Let me turn off the light here because the doesn't show that well with all the light. So this is really cool because you can see that the lines that have been changed, they're all highlighted. Okay. So this entire line has been changed, and over here, it even highlights the one single character that has been changed. And then we can go to over here. So over here we have an addition. Oh, no, it's skipping a whole bunch of lines, basically no changes. And over here we have a change on that line. And over here I think I removed a line here. I might have removed an empty line. And over here we added the parentheses around edx. And over here I inserted this gibberish in the new version. And over here I deleted this portion. I deleted this portion. There's no change for these 11 lines, so it's not even shown. And then over here I inserted the gibberish. So this is a quick and easy way to visually compare two versions of the same file.
Can you edit in here too?
Yes, you can. In other words, what I can do is I can go to this line here, and as I type, you can see that the difference goes away. Yep.
Is there a way to do vim diff one file and then have access to the mouse? I mean, like in Putty, you can't click somewhere; you got to scroll all the way down. Would this allow you to click to put the cursor somewhere?
I think you can install
GDM
is the package that you can install, and that will let you control the cursor using the mouse. I'm not sure whether it works in Putty or not, though. Oh, that's right. You guys don't like VI.
Yeah, we do.
Okay, that could be a problem. There are other visual different diff tools too. This is called a diff tool. Basically it takes the differences between the files and visually display the differences. Now in this class, it is not required that you know how to do this, but I can see down the line, okay, in other classes, you may find this kind of tool helpful. Any questions? Yep.
So how do you get the revised, the one that the file before?
How do I get it back?
Yeah.
I use this command here. I use co for checkout, co-l, and then the name of the file.
I guess the revised one before.
You can specify the version. You can specify, when you do co, you can say co-r and then a particular revision number. That works too.
Can you go forward and backwards on that?
You cannot go forward because you cannot travel in time, so it's always backwards. It would be nice if you can just check out the future revision, so you don't have to do it.
You want to go back and then you want to go back to the.
You can go back and forth. Yep. Okay. So this is a great tool. You can find tutorials online as well. Now this is as Chris said, this is a really archaic tool. The newer tools, one is called Get, G-I-T, is the name of the tool, and the other one is called Subversion or SVN. I personally use CVS, which is also kind of archaic by today's standard. Excuse me.
Nice ringtones.
That's the default ringtone. I heard that. If I had to choose, I would probably choose Initial D music.
We were kind of expecting it to be someone talking in Klingon.
You have a phone call.
The cock is not fresh. It doesn't move. All right. Well, where's my pain stick? All right. So, any questions about the exam question? No. Yep.
Is this one going to be open computer?
Is this one going to be what?
Open computer?
Open computer?
Yeah. We're doing it in the lab.
Yeah, we're doing in the lab, during the lab time. So you probably want to make, special provisions, because, some people may not, normally have time after the lecture time. So you probably want to arrange, something so they can stay here until at least 9:45. Plan for 9:45, because Walter will start to kick people out, at that time. Any other questions about the exam? Yes.
Are you going to require us finally to use Git or RCS or some other version control system to submit our code
In this class?
for this test?
For this test? That's an idea.
No.
That's a good idea.
Is the format of the test going to follow the format of this one?
The format of the test will follow the format of this particular one, yes. But obviously it won't be about GCF or LCM. It'll be about something else. So any questions about the format of the test? I will still have provisions, for partial credit, just in case people can get, 2 of the 3 subroutines done, they can still get partial credit for the 2 or 3 subroutines. Okay? But something has to be working to get credit. Okay, that's the whole deal. That's the whole deal. Is you might have several subroutines. You can get partial credit when 1 or 2 subroutines work, but something has to be working to get partial credit. Okay, and that's the price that's the price of working in the lab, because when you work in the lab, you have all the tools and should be able to get something to work. Yep.
Is the test going to be basically like this, like one large problem with different parts to it?
Yes.
Okay. But everything's going to be part of the same program.
But at the same time, partial credit can still be given because I can test, find factor without the rest of the program working.
Right.
I can test, find factor and find GCF without the rest of the program working. So I can incrementally test your code to see, up to which portion is working, and then assign partial credit accordingly.
But I'm saying it's not going to be something like this and then 3 other things.
No, it is. This is it. It's a practical test. You actually have program to decode, to debug, or you have to start to write actual your own code. But I won't have anything that is too complicated for you to write. But you do have to kind of fix programs. Or there will be like a missing statement, and I'll make it clear. Okay, this statement is not implemented in this program, so you have to add it to that particular subroutine or something along that line. Yep.
Will we have access to paper copies of the exam if we like writing it up, or can we just do that ourselves in the lab?
I can print paper copies too, but I don't want people to turn in, a printed or handwritten program, to grade, because this will be a whole lot more difficult to grade, when people turn in a handwritten version of it. Okay.
We can make that really easy. If we turn a handwritten one, you just give it an automatic A.
It depends on how it is folded.
We'll fold it into this beautiful crane and hand it in.
All sorts of origami.
What about an origami bat lift?
Deserve an A.
Paper cuts, huh? You can make it really sharp and make it a lethal weapon. All right. So there we have it. This is your practice exam, and I don't know when I'll go ahead and release the answer to this. I can put it on YouTube anytime I want to, because it's up to you guys to go to check the answer when you feel that you're ready to check the answer. So I think that's a good flexibility, because I don't have to disclose the answer on Thursday, because some people may want a little bit more time to work on it, but when you think you're ready, you can just watch the YouTube clip and find out what the answer is supposed to be. Okay. Any other questions about the practice exam or the exam on next Thursday, 9 days from today?
Is there a homework assignment also due on the exam day?
That's a good question. I haven't decided yet. I'll decide it on next Thursday. This Thursday, not next Thursday. Yep.
Maybe just make that a yes?
I'll think about it. Okay, so are there any other questions before we move on and continue to talk about parameters, local variables, and return values? No questions? Okay, let's go back and continue to talk about these things. Last time, I think we stopped with the use of the frame pointer, and also we talked about the non-negative end of the frame, which is basically everything that has a positive displacement from where EPP points to. Okay? Okay, let's do a quick refresh of what we talked about the other day by bringing back one of the spreadsheets that we worked on the other day. Because I think the spreadsheet actually works pretty well. I mean, it's a good way to show what happens on the stack as we execute those instructions. So we'll go ahead and take a look at the files that we captured on that day.
Is there at some point you can make a macro to resize cells and put a border on the right-hand side of the desired thickness?
I'll write Python scripts in OpenOffice.
Even better.
It forces me to learn how to write Python programs. Okay, so there we have we have this one. I kind of stopped at this point, because if I continue to work on these two instructions, that basically is your homework assignment. So we kind of stopped at that point. But when you look at the trace, which is in sheet 2, you can see how the stack or the content of the stack gets modified. The green line is the most important part because the green line. Can you guys see the green? Yeah. Okay. Because the green line represents where the frame pointer, or EBP, points to. Now, once we have the green line pointing here between column L and column M, I can have additional push instructions. And those push instructions do not change the displacement from the green line to the parameters anymore. Because the green line is a snapshot of the stack pointer at a very early stage of the subroutine. Okay. Now the one thing that you do have to remember is what is the green line pointing at, or what is the frame pointer pointing at. The frame pointer is always pointing to its own old value. It's the saved value of the frame pointer is what the frame pointer points to. Okay. Now I understand that this is assembly language programming, and we are doing all the coding by hand. So there's really no strict restriction that this has to be the case. But it is the case because it is the convention in C and C++, and this convention also allows us to debug programs by looking at all the previous frames so that you can identify how did I get to this particular subroutine? What are the parameters passed to all the other calls of subroutines before it gets here? Okay, we kind of talked about that last week too. Do you guys still remember that part? How we can use a frame pointer to go back to the previous frame, to go back to the previous frame, to go back to the previous frame? Kind of? Okay. The one thing right before old EBP, or in this case, that has a higher address, this is old EBP, this is old EBP, plus 4, or the displacement is 8, is 4 at this point, is the return address of the subroutine. After that, we have the parameters. So are we doing okay so far with this spreadsheet? This is what we talked about last Thursday. And I think this is really, 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 really important. Okay? Because at this point, we're going to talk about what happens to the other side of this green line. Do we have any use of the negative side of where EBP points to? That's the next question. Let's go ahead and write a program. And this time we use local variables. So first of all, I will write a subroutine in C first. It's not going to be a very impressive subroutine that doesn't really do anything. It returns void at this point because I haven't talked about how to return a value in a subroutine yet. So all the C functions that I can write at this point, they all have to return void because we don't know how to return a value yet. So let's say f has two integers, two parameters that are integers, and it has a local variable that I call t. And over here, let's just say that t equals x plus y, and that's the end of the subroutine. Okay. Obviously, if you wrote a subroutine like this in your CISP360 class, your professor will probably just laugh at it. It's not wrong per se, it just doesn't do anything useful. Yep.
Actually, it is wrong because you're missing the semicolon.
Oh, missing the semicolon.
Tactically,
Tactically
that's really
incorrect.
bad to see. It'll complain for hours. You fix it, they'll still complain about it because it was such an appalling mistake. True story.
True story. All right. Okay, so now how do we implement this program? Okay, how do we implement this particular subroutine using parameters on the stack? That's the question. Okay, first of all, I always start with OEBP gets 0 because the frame pointer, EBP, points to its own saved value. In other words, the old value of EBP is 0 byte from where EBP points to. Okay, what goes after that? The return address. So the return address is old EBP plus 4. Okay, the return address is 4 bytes higher than old EBP. And then after that, what do we have? We get to the parameters, but which one is the first one?
First argument.
Okay, which one is right next to the return address? How about that? X is right next to the return address because we push the parameters. Which one do we push first?
Last one.
Push Y
We push the last one first, which means the first one has the lowest address. So X is return address plus 4, and Y is X plus 4. Now let's just make sure that everybody understand what X and Y mean. X is not really the local it's not a parameter anymore, but it shares the name of the parameter. What I should have said here is offset to X from where EBP points to. But that's kind of long and really hard to type, so I just use X itself. But you have to understand that the symbol name that we use in assembly, at least in this standard, is the displacement from where EBP points to that thing. Is that okay so far? Okay. In other words, X should have been, the number of bytes, the displacement from where EBP points to the first byte of parameter X. But I'm just lazy and don't want to type all those, extra, words. So I'll just, write a comment here. X should have been named num bytes from where EBP points to the first byte of parameter X. How's that? Okay, so I just want to remind people that X is not really parameter X, it is a displacement. Okay, and so is Y. The big question now is, where's T? Now, first of all, who is responsible to allocate for the local variable T? The caller or the subroutine being called? The callee, the subroutine being called, because the caller doesn't even know, is not supposed to know, about the local variables inside the subroutine. Okay, now if the subroutine is responsible to allocate space on the stack for the local variable T, should local variable T have an address that is higher than the parameters or lower than the parameters? Lower than the parameters. Higher or lower than the return address? Okay, what about the frame pointer, EBP? Lower. That's right. That's exactly right. So that means in this case, T is going to the negative side of EBP. It is actually EBP minus the size of T itself. Since we are assuming that we're using 32-bit integers, we just subtract 4 in this case. Okay. So now what you can do is you can just draw a picture of the call frame. So the call frame would look like this. At the highest address, okay, let me just, high, okay, command, high address up this way. Okay, so what we have here is, Y has the highest address. Then we have X, because X is pushed last, and that's why it has a lower address. Then we perform the call, which means the return address is here. After we get into the subroutine, the very first thing that we do is push EBP. So that's why old EBP is here. Then we copy the stack pointer into the frame pointer. So EBP points to old EBP. And after that, we reserve the space for the local variable t. So this is what the call frame actually looks like. It is complete. We have the parameters, we have the return address, we have the saved value of EBP, and then we also have our local variable in this case. So the next question is, how do we make this happen? Yep.
We request an extra space on the stack, and
Yep.
we stick our head between our legs, kiss our asses goodbye, and hope that something didn't happen while we were busy allocating it. Wait, we don't have to do that last part. Just requested it.
Scratch that last part. Okay, so from the subroutine's perspective, okay, this is F, this is the subroutine itself. The very first thing we want to do is to save the value of EBP before we change it. Does everybody understand why we have to do a push L EBP? Because we are just about to change it. But I don't want it to appear to be changed from the perspective of my caller, because my caller wants EBP to be intact, to be its own frame pointer. So after we save it, we can now copy ESP to EBP to take a snapshot of the stack pointer. So from now on, it is at a stationary place. It does not change anymore. Then we are ready to allocate space for our local variable. Now, how would I allocate for the local variable here?
Push value.
What about doing something like this? Well, let's take a look at this one here. It is counterintuitive, but it works. Why do you think it works? What is t anyway? If you look at here, what is t? What is the value of the symbol t?
-4.
It's -4. In other words, we are adding -4 to the stack pointer. What is that effectively doing?
Lowering it by 4.
Subtracting
We are lowering the stack pointer by 4. So are we allocating or are we deallocating in this case?
Allocating.
We're allocating because the stack grows lower and lower. Okay. And this is how we reserve the space for our local variable t. After this point, I can push and pop registers all day long as the push and the pops match up. Everything will be fine. I can still get to every single one of my parameters and my local variable, even with all the additional push and pops. Okay, are we doing okay so far with this program? So now that we have the entire stack frame, call frame, set up, it is time to do the calculation. The calculation, which is here, well, let me do this trick here so we can look at the C code and work on the assembly code at the same time. Okay, so we're trying to implement this one single line in C. We want to add the values of x and y and then put it into t. Okay, well, we know that we cannot add a memory operand to a memory operand. Okay, we can only have up to one memory operand in any instruction. So that means we have to rely on the register anyway to store the intermediate result. Let's just say that I use EAX for that particular purpose.
Does it have to push EAX first? You should push EAX first.
As it turns out, EAX is a register that the caller can never expect not to be changed. In other words, if you are calling another subroutine, you have to pretty much make assumptions that EAX can be modified. Okay, but we can do that too if you want to. We can definitely save it before we. There's nothing wrong with saving it and restoring. It's just that most C subroutines will not expect EAX to be preserved anyway. So the pushing and the popping may not be helpful, but at the same time, it doesn't hurt either. Yep.
Should that add T be a direct operand and not an immediate operand?
It should be immediate operand because we are trying to subtract 4 from ESP. The label is defined to be -4. If I use a direct operand, then it will go to location in hexadecimal, FFFFFFC, and grab 4 bytes from that location and then add it to ESP. So you definitely want to have a $sign here. Yep.
Is EAX the only register that the caller assumes?
Yes. Yep. That's the only register.
So if we use EBX there, we would have to push it.
Yes.
Okay.
especially when your subroutine can be called from C. If it's only called in your other subroutine that you write, then you can make any assumptions that you want. But if you expect your subroutine to be called from your code compiled by the C compiler, then you have to save and restore the registers. Okay. So we push EAX here, and then after we push EAX, we'll just go ahead and initialize it first. Or we don't have to do that. We can just copy one of the operand or one of the parameters to it. Now, how do I get to parameter x in this case? Let's think about it. Let's think about what is parameter x and where is parameter x. Parameter x is a 32-bit integer that we push on the stack. Okay? Now, where on the stack is this parameter? Well, I can go through all the same explanations as from last week to explain where it is. But in this case, I have defined a particular symbol as the displacement from where EPP points to the first byte of that parameter. So given that, how do we get there using cisp addressing modes?
You can do x parentheses EPP.
Exactly. We use the base addressing mode. Okay. Now, you guys knew that this has to be useful at some point. Otherwise, I would not be talking about it at the very beginning of the semester. Is that okay? Does everybody understand, why this instruction will copy the value of parameter x into register EAX? We are not copying the address of the parameter. We are copying the value of the parameter, because we are going into that memory space and copy those 4 bytes into EAX. Are we doing okay so far with this instruction? Yep.
And I'm guessing using the base scaled index addressing mode is a good way to access array elements.
You can access arrays of certain types. Yes. Very good. So that's why they're handy sometimes. So the next instruction is just add parameter y to the same register. Then we can move the register into our local variable t. And as you can see, we can access our local variable t as if it is just a parameter. And that's because t is defined to be the displacement from where EPP points to the first byte of the local variable. Are we doing okay so far with this code?
Say that again.
Okay. You can see that we use the same addressing mode. We use the base addressing mode to access our parameter as well as our local variable, because all of those things are expressed as how many bytes is it away from where EBP points to, and as long as we can calculate the displacement from where EBP points to the first byte of x, y, or t in this case, we can use the base addressing mode using EBP as a base register. And this is particularly handy for stuff like that. So we are done with this calculation, and now it is time to exit. It's time to get out of this subroutine. Now when you get out, a very good idea is to look at all the instructions that you execute when you get in the first place, because we have to undo all of those operations, but in a reverse order. Whatever you do last is the first to undo, and then from that you just it's kind of like parentheses. You have to close the closest parenthesis first, and then the next one, and then the next one. So the first one that we have to undo is the push L EAX. So that means we have to undo that one first by restoring the value of EAX using pop L EAX. And then the next one is add L $t to ESP. Now the funny thing is we don't actually have to undo that one. Okay?
Because when you pop EPP back,
because we can do this. When you copy the frame pointer back to the stack pointer, you just got rid of all the local variables, no matter how many of the global variables you have allocated. Does that make sense? Sort of? Well, first of all, do we want to store the value of the local variable t anywhere when we are exiting the subroutine? Nope. So that means those 4 bytes are really useless to me at this point. I can just add 4 back to ESP to undo this, but if I do this, it does exactly the same thing. because the next item that I really need to get back to is the old value of EBP, and this gets me straight to the old value of EBP, and I'll be ready to do the pop L EBP instruction next. Go ahead.
So does those bytes still exist? Like, say those local variables, if you do go back to those?
Okay, that's
Are
a
they
kind of
still there?
that's a weird question because those bytes are still in memory. Your question is, are those bytes deallocated?
Yeah.
Okay. Before this instruction, they were still allocated. After this instruction, they're no longer allocated. If interrupts can use the same stack, then interrupts after this instruction can potentially overwrite those particular locations, which is fine because I'm really at the end of the subroutine. I really don't need to maintain the value of my local variables anymore. Yep.
So this is how we allocate memory on the stack, correct?
Sorry?
This is
This is
example of
deallocating.
allocating and deallocating memory on the stack.
Yep.
How do we allocate and deallocate memory on the heap?
You have to, there's no instruction to maintain a heap in assembly language. So what you have to do is either to implement your own heap management, subroutines. You can write it from scratch, or you can link it with a C lib and call the C functions instead. So you can call free and malloc and all the other good stuff from a C lib. Because your assembly code can link with your C lib subroutines. But it's not really a assembly programming specific topic in that case.
Okay.
Yeah. Okay, so the next item, which is the last item to undo, is the frame pointer. Because if you look at the beginning, we have the frame pointer set up here. And after that, we have one more thing to do, which is the return address on the stack. The return address is undone by the return instruction itself. Okay. So do we have any questions about this subroutine? It is not very useful, except it does illustrate all the concepts about parameters, and also in this case, local variables. Any questions about this? No questions? Okay. If there are no questions, then yes, go ahead.
So if there is no dynamic memory allocation in assembly, how is it done from C?
C calls free and malloc to do it. So they are basically library calls, to C-lib or libc, depending on how you look at it. But there's a library which is a collection of subroutines that you can link with using the linker, and some of those subroutines can maintain the heap. But in order to use the heap, you have to first call and initialize the heap data structure first. Then you can call malloc to allocate bytes, and then you can call free to deallocate bytes or resources to the heap.
Right.
And you can do the same thing in assembly, because now we understand how to pass parameters to a subroutine, and this is the same standard with all C programs as well. So technically, we can do it now. We can use the heap once we understand how to initialize it, because just knowing how to call malloc and free is not enough, because we also have to know how to get the heap initialized to begin with. And I have not looked up what function to call to initialize the heap. All right. So now that we are done with this part here, let me close this spreadsheet. Then we only have one thing left to do before the end of this class. Yep.
By the end of this entire class, not today, but the entire semester, will you have shown us how to call C functions?
Yeah.
A working example of C functions from assembly and assembly functions from C.
Oh yeah. Oh yeah.
Okay.
You will have an assignment like that too.
Excellent.
You will have an assignment where your assembly code is sandwiched. In other words, I will give you a C subroutine to call your assembly subroutine, and your subroutine will also have to call one of my C subroutine as well. So it will test both cases. Okay? Can your subroutine understand parameters passed by code compiled by the C compiler? At the same time, can you also generate the call frame that is necessary to call another subroutine that is actually written in C? So we'll get there. We'll definitely get there. But one step at a time. All right. So here we have a very simple C function. Okay, 5 as a C function returns the value of 5. Okay, it's in other words, the entire purpose of this seemingly useless and pointless subroutine is to illustrate how to return a value of 5. Now, I know this is not necessary. Okay, there's absolutely no necessity whatsoever to push EBP, copy the stack pointer to the frame pointer. But as a habit, I think at this point of this class, we should all just practice this day in and day out, just so that we know what instructions we have to execute in general when we get into a subroutine, and also what instructions we have to execute when we get out of a subroutine. The meat of this subroutine is just this part here. We copy the constant 5 into EAX, and that's how you return a value, a scalar, in C and also in assembly programming. So that's why EAX is special, because it is a register used to return values. Yep.
So if there's a value in EAX when you return, but it's a void function, EAX will be ignored?
EAX is still assumed that it is destroyed. Yep, even for a void function.
But
Yep.
if you're saying in this case it's not a void, it's a...
Yeah, this one is not a void function, it returns an int type. Yep. Yep.
Would you initialize EX first to like 0 and then move? Or?
No, because move 5 overwrites whatever EAX had, so it will, that's all you need. Because all we want is EAX to have a value of 5 when it returns, and this guarantees it. Any questions about returning a value? Yep.
What if some interrupt happens that just happens to change EAX?
It should not. ISRs should not change registers. If you write an ISR or interrupt surface routine, inside the ISR, obviously, you have to use some registers to do all the calculations and whatnot. But it is the responsibility of the ISR to save and restore the registers that it changes. And that's why, if you want to write an ISR in C, you can do that. But what the compiler will do is it will make sure that all registers are saved before passing control into the subroutine. And when you're exiting from the ISR, it will restore all the registers as well. Yep, that's what it does when you write an ISR in C. So are we doing okay with the return value concept? So this means, if I just apply this concept to the program that I wrote a little bit earlier, okay, I would just copy this to return value. Then I can just change the original code to int to return an integer type, and I'll just go ahead and return this without needing a local variable t. Yep.
The name of the file is local variable.
You're in the wrong file.
Undo.
Well, you can just revert it using RCS, right?
But this is more file. Okay. All right. I did not check it in. Okay,
Well,
so
it's not very useful.
I can do this. I'm just changing the program so it reflects, the actual code. So in this case, it doesn't make any sense to push and pop EAX because EAX is supposed to be the return value, and this is it. I just have to add X and Y into EAX and do the return, and I'm all done. Yep.
So the caller has to do something with EAX then when it gets...
The caller can choose to do something about EAX, because a lot of C functions return some kind of a value. But a lot of times, because we are bad programmers, we ignore the return value. So EAX does have the result of the calculation, but if the caller does not really need to use the return value, the caller can ignore the value of EAX. But if the caller wants to use that for some calculations, then it has to utilize the value of EAX before it gets destroyed by the caller itself. All right. Well, we are all done. We are with return values, but we are not. There's always, but, we are not done yet. So what I want you guys to do, besides, working on the test question, is to, I don't have a topic here. Okay, never mind. Let me see if I have it somewhere else.
We are.
We are kind of done. Okay, I cannot talk about that because I haven't talked about data structures yet. In other words, in C, you can return a non-scalar. Okay, a scalar is what? A scalar is an integer, a char, a pointer. Those are all called scalars, and they will all fit inside a 32-bit integer. If you return anything that is 64-bit and you have a 32-bit architecture, and you have to return the most significant 32 bits in EDX, and then the least significant 32 bits into EAX. That's the Intel convention. EDX and EAX kind of goes in pair a lot of times. What about returning a structure? Well, first of all, can you return a structure in plain C? I'm not talking about C++ here. In plain C, can you return a structure? The answer is yes, you can return a structure. Now, can you make sure that you can fit a structure inside EAX and EDX? No.
Create one, make it as a pointer, and then assign the pointer.
Exactly. That's exactly how it is done. You reserve the space on the stack, so the caller has to do that first. It has to reserve that space, and then what it does is it will pass the address to the allocated space on the stack to the subroutine. So there's an implied parameter in that case. So we'll talk about that after we talk about data structures. Then we'll go back to how to return an entire structure back to the caller. But at this point, we are all done with topic 9. Topic 9 is all done. So if you have not been keeping up with reading the notes, this is a good time to try to catch up. And don't forget about the homework assignment due on Thursday. Cheap megaphone. Yeah.